All right, this is for the review problems in Chapter 3. It's called Functions and Their Graphs. All right, so for the first problem, they want us to refer to Figure 326. So Figure 326 is this one right here. And we're looking to find f of 1. What this means is the y coordinate at x equals 1. Okay, normally if you had the function equation, you would just plug in x equals 1. But we do not have the equation, we have the graph. So we just want to find the y coordinate. All right, so pretty simple. This is your x-axis, and this is your y-axis. You go to x equals 1, you trace that to the graph. So the graph is right here. All right, and then you want to find the y-coordinate on the y-axis. So that is right there at -2. Answer B, -2. All right, number 2, they want to know where is the function decreasing. Decreasing, what does that mean? Well, decreasing just means that it has a negative slope. All right, so what does a negative slope look like? Well, that basically just goes down and to the right. All right, that's a negative slope. We know a positive slope, or increasing, would go up and to the right. All right, so this is what increasing looks like, but this right here is what we're looking for the decreasing part, the negative slope. So let's take a look at the graph, and then we'll get the interval where it is decreasing. Okay, so right here, if I could zoom in, right here we see it's increasing. It's going up and to the right. Now right here in this section, from here to here, we can see it's going down and to the right. It is decreasing. So on what interval for x, on what interval is it decreasing? Well, this is x equals 0, and this right here is x equals 1. So just this section in here is where it is decreasing. So it's just from 0 to 1. In the interval notation, we write it like that. Although they might have the square brackets. Let me see. Okay, they use the rounded parentheses for all of them. All right, because I guess at the point itself, it doesn't count. So yeah, it just runs from 0 to 1. These are the x values. So that is answer C. All right, for problems 3 through 6, we look at Figure 327. All right, so that's right here. Number 3, what is the domain? All right, that's pretty simple. The domain is the x values. All right, this axis here is the x-axis. And we can see the domain, it starts at x equals -2. And it runs to x equals +2. All right, so that is the x values from -2 to +2. And it includes, see the solid dot right here? It includes -2, and the solid dot means it includes +2. All right, so we use the square bracket because it includes that point. So it runs from -2 to +2, simple. Answer C. All right, number 4, what is the range? The range is simply the y values. All right, so let's look for the y values on the graph. The highest point, or points, is right here. Okay, we're going to the y-axis right here. So the highest point is at 2, and the lowest point is down here, both of the lowest points. They're down here. This is y equals 1. This is y equals 0. All right, so it runs from 2 to 0. And it includes 2 and 0. So it's just 0, comma, 2 with the square brackets. So that is answer A. Now, if you look at the answers, why is answer B incorrect? It looks like it's almost the same thing. And that is because on a number line, if you go on a number line and you work from left to right, the smaller values are on the left and the larger or greater values are on the right. So if you have 0 and 2, the 0 should be on the left of the number 2, okay? We count up going this way. We don't count going to the left. So that's why B is incorrect. This is the correct way to write it. Number 5, what is the average rate of change of the function between x equals -2 and x equals +1? All right, so for average rate of change, that's just the same as the slope. Okay, so we know the formula for slope is the change in y divided by the change in x. So change in y is basically just y2 minus y1 divided by x2 minus x1. All right, the order you subtract doesn't matter so long as you do it in the same direction. All right, so I like to do the denominator first for these values, and the x values are going to be -2 and +1. All right, so I'm going to do -2 minus 1. Now, you could do it the other way if you want, as long as you do the y values going the same way. Well, how do we find the y values at x equals -2 and x equals +1? You simply plug in these values in the equation, or you evaluate them on the graph. All right, so y2 is going to be f of -2. This is the y coordinate at x equals -2. And the y coordinate at 1 is going to be f of 1. All right, so we need to go to the graph to find out these values. First, let's find f of -2. Okay, we're supposed to go to x equals -2 and find the y coordinate. So let's do that. All right, here's the graph. This is the x-axis. I'm going to go to x equals -2. I'm going to trace that to the graph. All right, that's right here. And the y coordinate at -2 is actually +2. All right, so f of -2 equals 2. Sub that into the equation. F of -2 is going to equal 2. And that's minus f of 1. All right, so again, we're going to x equals 1. We're going to find the y coordinate. All right, so here's the graph. Here's the x-axis at x equals 1. We land right on the graph. So what's the y coordinate right here? That is just 0. All right, this is the y-axis. That's why I traced it here. So f of 1 equals 0. Simple. All right, so in place of f of 1, I'm going to put 0. -2 minus 1 is -3. 2 minus 0 is 2. That's divided by -3. And typically, we don't leave the negative in the denominator, so it's just -2/3. All right, and that is answer B, -2/3. Number 6, is the graph in figure 327 symmetric? Okay, and their answers are yes with respect to the x-axis, with respect to the origin, with respect to the y-axis, or no. All right, to look for symmetry when you're given a graph, you want to look for a mirror, okay, or like a reflection. All right, so that's what I'm going to do in figure 327. Now, if you look at figure 327, where is the mirror or reflection? Well, look right here. If we drew a line down the y-axis, we can see it's the same thing on this side on the right and on this side on the left. So this here is the y-axis. So this is clearly y-axis symmetry. All right, because it reflects the same on both the left and the right. Okay, if it were x-axis symmetry, the mirror would be right here on the x-axis, and whatever was on the top of the x-axis would be the same thing underneath. And finally, if it were origin symmetry, you would draw in the line y equals x, and the part underneath the line would be the same as the part over the line as well. That would be origin symmetry over the line y equals x. So we said it was y-axis symmetry. That is answer B, y-axis symmetry. All right, number 7, find the average rate of change for this function between x equals 0 and x equals 2. All right, so we already said before average rate of change is the same as the slope. And the slope formula is change in y divided by change in x. All right, the x values are 0 and 2. So for the denominator, I'm just going to do 2 minus 0 on the x's. All right, for the numerator, the y values, you have to plug in these x values in the function. So for the number 2, x equals 2, the y coordinate is f of 2. And for x equals 0, the y coordinate is f of 0. All right, and we have the f of x function right here. So f of 2 means we plug in x equals 2 in the function for f of x. All right, so we're going to plug in the 2 right there. All right, for f of 2, we're just plugging in the 2, so it's going to be 1 divided by 2 plus 1. All right, so for f of 2, that's going to be 1 divided by 2 plus 1. So, of course, that's just 1/3. All right, in place of f of 2, I'm going to write 1/3. And that's minus f of 0. All right, so for f of 0, we're plugging in x equals 0 right here in the f function. So it's going to be 1 over 0 plus 1. Okay, and 1 divided by 0 plus 1 is 1 over 1, or just 1. So for f of 0, we have 1. 2 minus 0 is 2. All right, so we need a common denominator. 1, we have a denominator of 3 here, and the number 1 is the same as 3 over 3. All right, so 1/3 minus 3/3. Well, 1 minus 3 is -2, and that's divided by 3, and this denominator is 2. All right, so we have to use keep, change, flip. We see the bottom denominator is the same as 2 over 1. So keep -2/3, change division to multiplication, and flip 2 over 1, make it 1/2. All right, and now we are multiplying instead of dividing. 2 over 2 cancels, and we have -1 in the numerator and +3 in the denominator. So that right there is your average rate of change. Negative 1/3, answer B. All right, number 8 is the function even, odd, or neither. All right, so there's a few steps to determine this. First, you want to evaluate f of negative x. All right, and if f of negative x equals the original, that means it's going to be even. All right, so if f of negative x equals the original, it's going to be even. Alternatively, if f of negative x equals the negative of the original, it's going to be odd. All right, so this right here is the negative of the original. All right, so it's going to either be even, odd, and if it's not either of those, then it's neither. All right, so here's the function, f of x equals this right here. All right, so let's do f of negative x. That means we are plugging in negative x wherever we see an x. So that's going to be 3 times negative x squared. All right, make sure you use parentheses when you square it, and that's plus 5. All right, and negative x times, well, we have the 3. Negative x times negative x is positive x squared. And I meant to say plus 5 right here. All right, this is plus 5. Now let's see. Does this equal the original? Yes. That equals the original f of x. All right, and we said if it equals the original, that it's going to be even. So since f of negative x equals f of x, it's even. So that is answer A, even. All right, problem number 9. Same type of question. We're looking at this function right here, and they want us to say if it's even, odd, or neither. Okay, the first step, as always, for the even, odd, or neither is to solve for f of negative x. That means we are plugging in negative x wherever we see an x. So we start with the 3, and x to the third is going to be negative x to the third. Again, always use parentheses with the exponents. And then we have plus 5. All right, so we have 3 and negative x to the third. If you multiply a negative 3 times, that's going to end up being a negative. So this is just going to be negative x to the third plus 5. And now since this is positive times a negative, we can just take the negative and put it out front. So it's negative 3x to the third plus 5. Now look at this here and look at the original. Does what we got equal the original? No, this does not equal the original. So far it's not even. Now let's test for odd. We have to do the negative of the original. So negative f of x means we are going to negate this entire function, 3x to the third plus 5. So we're taking the negative of 3x to the third plus 5. Okay, notice f of negative x is not the same as negative f of x. Those are two different things. All right, distributing the negative, we have negative 3x to the third, and we have negative 5. Now, does that equal f of negative x? Does that equal negative 3x to the third plus 5? No, it does not. All right, negative f of x does not equal f of negative x. All right, we have it right. We have f of negative x right here. And we can see it doesn't, they don't equal. So it's not odd. All right, if it's not even and it's not odd, then it's just neither. All right, so that's it. Answer C for number 9. It's neither. All right, last one. Even, odd, or neither. So here's the function right here. Might as well just highlight it. This is the function. All right. So first step, as always, for the even, odd, or neither, we're going to solve for f of negative x. That means we sub in a negative x wherever you see an x. So 4x squared is going to be 4 parentheses negative x squared. And that's divided by x to the third. But the negative x gets plugged in there, so that's going to be negative x to the third. And the last term is plus x, but it's negative x, so it's plus negative x. All right, so let's see. When you square a negative, it becomes positive. So negative x squared is just positive x squared. When you cube a negative, it stays negative. Remember we said if there's 3 negatives multiplied, that's just going to be a negative. So this is still negative x to the third. And plus negative x is the same as minus x. All right, so let's see. This negative can just be moved to the numerator or out front. Same thing. So it's negative 4x squared over x to the third minus x. Let's compare that to the original. Negative 4x squared over x to the third minus x. This is positive 4x squared over x to the third plus x. All right, so this does not equal the original. So that means so far that it's not even. All right, second test is to take the negative of the original, so negative f of x. So we are going to negate the entire f of x function. So use parentheses, and we're going to negate this whole thing. 4x squared over x to the third plus x. Okay, 4x squared over x to the third plus x. Distributing the negative, we have negative 4x squared over x to the third. Distributing the negative to the positive x, we have negative x. So this right here is negative f of x. All right, and does that equal this right here? This was f of negative x, right? Because we just did that a minute ago. This was f of negative x. We have negative 4x squared over x to the third minus x. That's what we have here also. So it equals f of negative x. Okay, so since they are equal, that makes it odd. All right. If f of negative x equals the negative of the original, it's odd. All right, we proved that it wasn't even, but it is odd. So that is answer B.